Very good afternoon, dear student. I hope I'm audible and you can see me as well. If I'm audible, please write down yes in the chat box. Sharing the screen with you. I hope I am audible. Lot of disturbances there. Am I audible? Yes, okay. Lot of disturbances there. Let me continue with the topic. Okay, fine. So we are at the end of the syllabus. We're about to finish with the unit. Let me continue with the topic. About to finish with the unit. If some part of the unit is being left here, we'll be continuing it in the next class. Because since the topic is new, I need to just see to it that I do not leave any of the topic. So after going to the scope of the syllabus, I'll just see to it if anything has been left, I'll be finishing that off in the next class. Okay, fine. So basic of energy. Course objective. There are 3 course objectives with 6 course outcome. And content of the unit is being told to you from time again and again. So the one which has been highlighted with the red has been done in the previous class, and today we are going to deal with the basics of energy. Some part has been done in the previous class. Some of the topic which was been done in the previous class will be discussed here as well. So let's see. The course outcome for unit 1 is, after completing the unit number 1, that is basics of energy and solid fuel, it has been expected that the student will be able to obtain the knowledge of solid and gaseous fuel and their calorific value determination. So the majority of the part is being taught to you in the class. You have completed how to calculate the calorific value by Baum and Boyce calorimeter. Then we have also studied the various types of fuels and their example. So here in this unit, the important term which we need to remember is nothing but the calorific value and its determination. So this much topic I'm going to cover today. Let's see how much we can go. Now, before moving ahead, this has been explained to you earlier as well in the previous classes, just brushing up the topic. So what is fuel? Fuel is nothing but a substance on combustion produces certain amount of energy, and that energy is being utilized in doing work done. Okay, so that substance has been termed as fuel. So the fuel should have certain good qualities, or it should have certain characteristics, or it should have certain properties. So what are those? Now, since you have done the whole of the unit, you will be able to answer it in a very easy way. What it should have, what the fuel should have, it should possess very high calorific value. Higher the calorific value, more will be the significance or importance of fuel. Okay. Next is, it should have proper ignition temperature. What do you mean by proper ignition temperature? Ignition temperature is nothing but the temperature at which the fuel starts burning, okay, or it catches fire. So that should be proper. If it is too high, then it will be very difficult for us to burn the fuel. And if it is very low, so it will be very difficult for us to store the fuel. Okay, so you should have a fuel, or you should select a fuel which should have a proper ignition temperature. Then after the combustion, the fuel should not produce any poisonous product. What do you mean by poisonous product? Like, for example, carbon monoxide. You are very well aware that if you inhale carbon monoxide, it goes into the blood and it forms carboxyhemoglobin, which does not allow, or which reduces the oxygen carrying capacity of RBC, resulting in fatality or resulting in unconsciousness or maybe death. Fine. So we need to see to it that the fuel should undergo complete combustion, and on complete combustion, it should not produce any harmful or poisonous product. It should have moderate rate of combustion. That means it should not burn in a very fast way, or it should not burn in a very slow or very less rate. Why? If it is been burning at a very faster rate, you will not be able to convert the energy into work done. So it becomes very difficult for us to handle the fuel. Henceforth, the combustion rate should be moderate, not too fast, not too slow. Next is, the combustion should be easily controllable. You should easily control the combustion. That means it should be at our will to start the combustion and to stop the combustion. If it is out of control, then it becomes very much dangerous. Then it should not leave behind much of ash on combustion, right? For that, we need to choose the coal which should have less percentage of ash. This I have told in the previous class in proximate and ultimate analysis. It should be easily available and it should be in plenty, right? Have low moisture content. This has been taught to you in the previous class. It should have low moisture content. Why? Because if the fuel is having moisture, so majority of the calorific value will be taken away by the water or the moisture for evaporation. So we are going to land up with very less calorific value. Henceforth, moisture is undesirable, or it should be free from moisture. It should be cheap, yes. It should be available for everyone, because everyone needs food, and food is being prepared with the help of fuel only. So this becomes one of the commodity for everyone from every corner of the society. Okay, and then it should be easily stored and transported. You cannot see it because of the label. It should be easily stored or it should be easily transported. The cost of transportation increases, no doubt the cost of the fuel also increases. So you need to choose a fuel which is being easily stored and easily transported. So these were the few characteristics of fuel. Let's see what is there. The next, we need to talk about the thermal basis of energy, that is nothing but fuel. So fuel is a form of energy. Okay, so you have studied there are various forms of energy like chemical energy, electrical energy, mechanical energy, kinetic energy, potential energy, thermal energy, so on and so forth. Okay, but when we talk about fuel, only one energy which has been associated with the term fuel is thermal energy. No doubt there is light energy also, but the major concern here is the thermal basis of energy for fuel. Let's see what is thermal energy content of the fuel. So we know that fuels are being converted into useful energy according to their heat content. That means individual fuel has certain heat content hidden into it. And on that hidden heat content, we are going to use that fuel. For example, if you take liquid fuel, so in liquid fuel, we are being utilizing the liquid fuel. It is having certain amount of energy. So we are utilizing the liquid fuel for combustion, and we are also been utilizing the liquid fuel for uh, vehicles. Okay, but you are not going to use the petrol and the diesel for cooking purposes in your kitchen stove. So why what we have done is we have done the classification, or we have converted the fuel into its specific application on its basis of heat content. जिसका जितना heat content रहेगा उसके हिसाब से ही उसका energy रहेगा. Clear? जितना ज़्यादा heat content उसकी application अलग रहेगी. For example, you cannot use coal in your vehicles, two-wheelers. Why? Because the heat content and the operation, you can say, parameters are very much different. Agree? So we have studied that the heat content can be expressed in many ways. So for a fuel, the heat content is basically being measured in BTU, that is British Thermal Unit. And I have already taught you about the calorific value and its unit in the previous class. So you can correlate those terms here. Okay, so there is another way of expressing heat, that is centigrade heat unit, CHU, joules per gram, calories per gram, or kilocalories per kg. Clear? Now when we talk about energy, thermal energy content, then we need to talk about the heat capacity as well. Everything has been interrelated to each other. So what is heat capacity? The other word which has been given to heat capacity is thermal capacity. Same word, thermal energy content and thermal capacity. So it's a physical property of matter which has been defined as the amount of heat to be supplied to a given mass of material to produce a unit change in its temperature. That means we need to supply a heat, little amount of heat to a given mass of material so that the change in temperature is 1 degree Celsius. Am I clear? I can see only 42 people joining the class. The rest of the class is, I suppose, sleeping or they are having their lunch. Is it clear now? It's all theoretical. I suppose all are sleeping. No worries. Let me continue. Okay, someone says, Ruxana says, yes, they understood. Fine. Moving ahead. So, the SI unit of heat capacity is basically joules per Kelvin. Okay. For example, just understand the term heat capacity or thermal capacity with a very simple example. At a temperature of 25 degrees Celsius, the heat required to raise the temperature of 1 kg of water by 1 Kelvin is 4179.6 joule. So the specific heat capacity of water is being defined as same, that is 4179.6 joules per kg per Kelvin. फिर से आप सोचिए इसको, फिर से पढ़िए. It is nothing but the heat which is being supplied to a given mass of material so that the change in temperature is 1 degree Celsius. It can be 1 degree Celsius or it can be 1 degree Kelvin. Okay, तो जितना भी एनर्जी हम देंगे टेम्परेचर को राइज करने के लिए 1 डिग्री सेल्सियस, उसको हम बोलते हैं थर्मल कैपेसिटी और हीट कैपेसिटी. क्लियर? नाउ अब हम देखते हैं हीट कैपेसिटी फॉर्मूला क्या चीज है. हमें ये पता है कि heat energy is nothing but the measure of the total internal energy of a system. This also includes both the kinetic and the potential energy of the molecule. So when I say ki we convert the water into vapor, this means earlier the water was having certain amount of potential energy and kinetic energy, but when I provide heat to it or energy to it, all the potential energy has been converted into kinetic energy. The molecules have been moving randomly, and the energy is so big that the molecules they start leaving the surface or they start leaving the state. So when they are leaving the state, that means from liquid state, they are being moving into the vapor state. So they are carrying away the energy. So whole amount of energy is nothing but the total internal energy of the system. अभी जब हम total internal energy बात करें तो we'll be talking in terms of its atoms and molecules. We are going to talk in terms of molecular level. ठीक है? So it has been seen that the internal energy of a system can be changed by either supplying the heat energy or by doing work on it. It is up to us what we want to do. If we want to convert from one phase to another phase or from one system to another system, we can do it by either supplying the heat energy or we'll make the system do certain work so that there will be change in the system. The internal is found to increase with the increasing temperature. अभी हमने बात किया कि water रूम टेम्परेचर पे है उसको वेपराइज करना है तो हमें क्या करना पड़ेगा वी नीड टू सप्लाई एनर्जी टू इट ओके एनर्जी देंगे तो क्या होगा उसके अंदर का जो सिस्टम है सिस्टम कौन है अंदर द मॉलिक्यूल्स ऑफ वाटर राइट सो दैट आल्सो चेंजेस so you are supplying temperature you are supplying heat so the system is like moving in a random way or the molecules are absorbing heat and then they start moving randomly. So automatically what has been happening? The system is increasing in temperature. This increase in internal energy basically depends upon the temperature difference and the amount of matter. जितना ज़्यादा डिफरेंस रहेगा टेम्परेचर का उतना वक्त लगेगा ठीक है थोड़ा सा पानी अगर आप गर्म करेंगे तो जल्दी गर्म होगा बट लार्ज क्वांटिटी ऑफ वाटर अगर आपको गर्म करना है तो यू नीड टू गिव लार्ज अमाउंट ऑफ वाटर एंड इट विल रिक्वायर लार्ज अमाउंट ऑफ टाइम so the increase in temperature or you can say when there is randomness in the internal energy it is because of the temperature difference and on the amount of matter. So heat capacity is been defined as the amount of heat energy which has been required to raise the temperature of a given quantity of matter by 1 degree Celsius. So ये हमने पहले भी पढ़ा था कैलोरीफिक वैल्यू का भी डेफिनेशन ऑलमोस्ट सेम है इसका भी डेफिनेशन तकरीबन मिलता जुलता है तो अब we again repeat the definition. Heat capacity is defined as the amount of heat energy required to raise the temperature of a given quantity of matter by 1 degree Celsius. ठीक है तो heat capacity for a given matter it basically depends upon its size or quantity no doubt and hence you can say it is an extensive property. Okay. The unit of heat capacity is joules per Kelvin or joules per degree Celsius. All of these topic that is related to heat, thermal energy, then heat capacity, sensible and latent heat, you have done in your 11th and 12th standard. It is just a revision for you. Mathematically, we can express the heat capacity as Q is equals to C into delta T, where Q is the heat energy required to bring about the temperature change of delta T. C is nothing but the heat capacity of the system under study. Let's talk about another term which is new to you, sensible heat. What is sensible heat? कुछ नहीं है सिंपल वर्ड्स में अगर आप समझने की कोशिश करेंगे वो हीट जो हम सेंस कर सकते हैं उसको हम बोलेंगे सेंसिबल हीट फॉर एग्जांपल आपको बताना चाहूंगी टेक अ ग्लास ऑफ वाटर Place 2 to 3 tablespoons of glucose into it and stir the water. What you will observe. Won't you feel the glass has turned cool or it is very getting cooler and cooler? You must have sensed that, yes? So what is that? It is nothing but the sensible energy. The water is turning cool or the system is becoming cooler. It is absorbing energy. So it is an endothermic reaction. So you can easily sense it. So that is nothing but sensible heat. So sensible heat is nothing but the energy required to change the temperature of a substance with no phase change. फेस चेंज नहीं हो रहा है यहाँ. सॉलिड से लिक्विड में कन्वर्ट नहीं हो रहा, लिक्विड से गैशियस में कन्वर्ट नहीं हो रहा. इट इज इन द सेम फेज बट देयर इज सर्टेन चेंज इन द टेम्परेचर. तो अभी हमने आपको जो एग्जाम्पल बताया वो कौन सा था कि भाई एक ग्लास पानी में हमने ग्लूकोज डाला, सेम फेज है, कोई चेंजेस नहीं हुआ, लेकिन जो ग्लास था वो काफी ठंडा हो गया. सो ठंडा होना इज नथिंग बट अ इंडिकेशन ऑफ सेंसिबल heat. Okay, just to explain you the concept in a simple language, I've taken that example. Okay. The temperature change can come from the absorption of sunlight by the soil or by air itself. अभी हम देखेंगे when we move from shade to sunlight or to an area which has been exposed to sun, you'll see the warmth. You can easily sense the heat. Yes, so that is nothing but sensible heat. Sensible heat is literally the heat that can be felt. जो आप जिसको महसूस कर सकते हैं, that is sensible heat. It is the energy which is being moving from one system to another that changes the temperature rather than changing the phase. Move हो रहा है एक सिस्टम से दूसरे सिस्टम में, लेकिन फेज चेंज नहीं हो रहा है. सिस्टम कुछ भी हो सकता है. जैसे आप एग्जांपल ले लें, एक धूप का हिस्सा है और एक छांव वाला हिस्सा है ना, शेडी एरिया एंड अ वेरी sunny area. So system is different, phase is same. Okay. For example, it warms water rather than melting ice. Another example you can take, adding heat to water can raise the temperature or change the phase. समझ में आ रहा है? ठीक है. जब आप आइस को मेल्ट करते हैं तो आप देखेंगे कि वहाँ वो मेल्टिंग जो हो रहा है, पानी जो है, दैट वाटर रिमेन्स वेरी कूल फॉर अ वेरी लॉन्ग पीरियड ऑफ टाइम. मॉलिक्यूल्स पास पास में थे, अभी बिकॉज ऑफ द अब्सॉर्प्शन ऑफ हीट दे आर सेग्रीगेटिंग, स्प्रेड हो रहे हैं, लेकिन वो जो पानी था इट इज कूल फॉर अ वेरी लॉन्ग पीरियड ऑफ टाइम. तो फॉर सम टाइम फेज जो है वो क्या है, सेम है, वाटर ही था. सिस्टम क्या हो रहा है, सिस्टम अभी वो ही है, पानी काफी देर तक रहेगा, तो सिस्टम रिमेन्स सेम. ठीक है, और फेज चेंज नहीं हो रहा है उसमें. नेक्स्ट वर्ड इज लेटेंट हीट. ये भी हीट से ही रिलेटेड है, आपके फ्यूल से ही रिलेटेड है. लेटेंट हीट को मैं सिंप्लीफाई और सिंपल वे में सिर्फ यही करूंगी, इट इज द हिडन हीट, जो छुपी हुई रहती है, जो बहुत ज्यादा इंपॉर्टेंट है. Latent heat is nothing but the energy absorbed or released by a substance during the chain in its physical state. That is when from solid to liquid or from liquid to gaseous or vice versa, that occurs without changing its temperature. So that is known as latent heat. So in other words, we can define latent heat as the heat or energy that is being absorbed or released during a phase change of a substance. It could be from a gas to a liquid or from liquid to solid or vice versa. Latent heat is basically being related to heat property known as enthalpy. Enthalpy, entropy, ये सब आप लोगों ने 11th 12th में पढ़ा हुआ है, तो it is being known to you. I'm just brushing up the topic and I'm just trying to correlate these terms to the topic. There are various types of latent heat, and we should also consider that latent heat is the temperature of a substance which remains constant. The तो लेटेंट हीट जो है वो कांस्टेंट रहेगी. अभी मैं आपको डायग्राम दिखाऊंगी, उसमें आप समझ जाएंगे. As far as the mechanism is being concerned, latent heat is the work that is being needed to overcome the attractive forces that holds the molecules and the atoms together in a substance. Let us take an example. Suppose a solid substance is changing to a liquid. Solid is changing to a liquid. It needs to absorb energy to push the molecules into a wider, more fluid volume. Similarly, when a substance changes from a gas phase to a liquid, the density level also needs to go from lower to higher level within the substance that needs to release or lose energy so that the molecules come closer together. Okay. In essence, we can say that this energy that is being required by substance to either freeze, melt or boil is said to be latent heat. तो एक ऐसा हीट, एक ऐसा एनर्जी रहेगा जहां से चीजें जो है कन्वर्ट हो रही है, चेंज हो रही है. सॉलिड से लिक्विड में आ गया, लिक्विड से गैसेस में चला गया, गैसेस से वापस लिक्विड में आ गया, लिक्विड से वापस सॉलिड में चला गया. तो या तो हम अब्सॉर्ब करेंगे उतनी एनर्जी, हम नहीं अब्सॉर्ब करेंगे, द सब्सटेंस अब्सॉर्ब करेगा, या तो वो उतना लिबरेट करेगा. ओके, वो जो एनर्जी है जो छुपी हुई रहती है उसको हम बोलते हैं लेटेंट हीट. तो लेटेंट हीट इज बेसिकली बहुत अलग अलग तरह की लेटेंट हीट होती है. जैसे लेटेंट हीट ऑफ एवापोरेशन है, लेटेंट हीट ऑफ कंडेंसेशन है, लेटेंट हीट ऑफ स्टीम है. ठीक है. So the latent heat is being associated with melting a solid or freezing a liquid is known as latent heat of fusion or heat of fusion. That which has been associated with vaporizing a liquid or a solid or condensing a vapor is known as heat of vaporization or latent heat of vaporization. The latent heat is basically been expressed as the amount of heat per mole or unit mass of the substance undergoing a change of state. Physical state में changes आएंगे solid liquid to gaseous or vice versa. This is the diagram through which you can easily understand. See, the temperature has been rising and heat has been added continuously. What has been happening? We can see the solid one, right? So after such, as the temperature rises, heat has been added to it. We can see the solid is being, it started melting, right? देखिए वो धीरे धीरे मेल्ट होता जा रहा है, एक टेम्परेचर तक पहुंचेगा. सो दिस इज नथिंग बट एन ऑप्टिमम टेम्परेचर जहां पर वो, जहां से या तो वो वाइस वर्सा जाएंगे, या ये जो टेम्परेचर दिख रहा है हम उसको बोल सकते हैं लेटेंट हीट ऑफ ईदर मेल्टिंग दैट इज फ्यूजन और फ्रीजिंग, लेटेंट हीट ऑफ फ्रीजिंग. सो दिस बिकम्स कॉमन टेम्परेचर. नीचे गए तो क्या होगा, सॉलिड बन जाएगा, और ऊपर गए तो क्या होगा, लिक्विड बन जाएगा. द सेम वे आप देखिए लिक्विड से ये जा रहा है गैसियस स्टेट में. आप यहाँ क्या देखिए, जैसे जैसे एनर्जी बढ़ाते जा रहे हैं, टेम्परेचर बढ़ाते जा रहे हैं, तो व्हाट इज बीन हैपनिंग कि जो लिक्विड था वो धीरे धीरे कन्वर्ट हो रहा है गैसियस फॉर्म में. अगर हम वाइस वर्सा करेंगे तो यू विल सी द कंडेंसेशन प्रोसेस. ठीक है. सो मेल्टिंग इन हायर ऑर्डर एंड फ्रीजिंग इन लोअर ऑर्डर, डिक्रीजिंग साइड में. उसी तरह से वेपोराइजेशन हायर ऑर्डर में जाएगा एंड कंडेंसेशन जो रहेगा वो डिक्रीजिंग ऑर्डर में आएगा. ठीक है. Am I clear? Basically, this concept is related to thermodynamics. I'm not going in much detail about the thermodynamics part here. If time permits, if we have time left, then I'll be brushing up the topic again in terms of thermodynamics. Let's see next. Now the specific latent heat. It is the characteristic that basically helps in measuring the warmth or the heat that is being consumed or discharged when a body experiences a steady temperature rises. So specific latent heat has been given by L is equals to Q upon M, where L is the specific latent heat, Q is the heat retained or discharged, that is gained or loses or absorbs, M is the mass of the substance. Okay? So the most widely recognized kind of consistent temperature forms are the stage changes. For For example, we have been using the word solidifying, vaporization, okay, liquefying, so on and so forth. So the word latent basically cover ups inside the atom until the stage is being changing from one to another. For example, when I use the word vaporization, it means the molecules were earlier from liquid state, now they have been moving into the gaseous state. Okay. It is specific since it has been communicated as far as vitality per unit mass. The well-known mass unit of specific heat are joules per gram and kilojoules per kg. So these are the units for expressing specific latent heat. So we have the reference here, as I've told you, Fidara and Jen we'll be using. Going through the scope of syllabus, we need to have or we need to solve the numericals on heat capacity as well. So we'll see to it that is being covered up here in the class. That's all we have for today's class. If you have any query and any question, you may please post the question in the chat box so that I answer it. Is the topic clear to you? Sharing the attendance link in your WhatsApp classroom. No question. Students, you have been requesting me to like I need to revise the topic of analysis of coal. So I'll do that again. We'll have the I'll revise the topic once again with you, right? Okay. I have no other queries with you. No queries. Sharing the attendance link with you in your. See, in Google Classroom, I'll be posting all the links of the YouTube so that topic wise you can, whenever you feel like revising, you can revise it. It will be there. So the Google Classroom is basically for section A only. Okay. Section C will be taken care afterwards. Thank you, dear students. That's all we have for today's class. Stay safe, stay healthy, protect yourself, be happy, study well. Okay, good day.